All right, so we're taking a look at, I think this is recording. We're taking a look at skill packet 5, which is exponential functions and log functions. And in skill 5G, we're solving equations. And I did it again. Where's my, there it is. Um, Here in number 8, we are solving an exponential equation. So we've got a problem. We've got this variable x, but it's up as an exponent, and I don't have any way to get that x by itself when it's an exponent. That's where the logs come in, and that's where this property of the product rule is going to come in. If I take the log of each side, or the natural log of each side, then I have this product rule that says this coefficient, that I can bring this down at this exponent I can bring down as a coefficient. I think I said that backwards, but all right. So on the left hand side I see two factors. The factor of interest is here is the one that contains my variable. So I need to cancel this other factor by dividing both sides of this by the log of 2. So on the left hand side I'll get the factor I want, and on the right hand side I have log of 6 divided by log of 2. Now since that's not multiplication, this is not 6 divided by 2. This is log of 6 divided by log of 2, and if I have the log of 6 divided by the log of 2, it's definitely not the number 3. Okay? That the log of 6 is not the number 6. And this log of 2 is not the number 2. And it doesn't mean log times 6. So you can't, you have to resist the temptation to cancel logs and go 6 divided by 2. That is totally incorrect. So let's multiply both sides of this equation by negative 6. Negative times negative is positive. 6 divided by 6 is 1. So if I multiply this guy by a negative 6, then this is what we get. So I don't see an advantage of taking this coefficient and pulling it up as an exponent. I'm just going to leave it like this. That's easy enough to punch in the calculator. I've got this negative 6 times the log of 6. Don't forget to close that parenthesis. Divided by the log of 2. And to 3 decimal points, I get 0.510. So this fraction is the exact answer, and this is an approximation to that. I can see the calculator, internally carries this out to a lot more decimals than just 3. So if I have 2 raised to the opposite, and if I tell the calculator to recall that answer that it previously did, and then divide that by 5, I'm going to get something really close to 6. Okay, I've done something wrong here. Alright, what went on? Okay, I see exactly what I did. You probably, I couldn't read my own handwriting. This is negative x over 5. Why did I change this denominator of 5 mysteriously to a 6? Well, because I'm an idiot. That should be 5. That should be 5. That should be 5. And of course that's going to change this. So it's good that I checked it on the calculator. I'm sorry that I'm wasting your time doing this a second time here. So if I have negative 5 times the log of 6 divided by the log of 2. Alright, so my approximation to this solution, here's the exact answer, and here's my approximation. And what I was trying to say before is that the calculator stores that answer internally. And now this time I should get something ridiculously close to 6. There you go. Now, if I had used my approximation, it might not quite equal 6. But I'll bet it will with the 3 decimals. Okay, what did I do? Oh, I apologize. When you take the opposite of x, the opposite of a negative number, my goodness, I should have keyed this in. Like this. And it did get 6. Okay, well, sorry about that. Let's move on. All right, so on the left-hand side here, I have two terms, and the term that has my variable, the one of interest, is this term. So I need to get that by itself, and so I need to subtract 2 from each side. So I've got log base 5 of x is equal to 1/2 minus 2. But since I have a fraction, I'm going to write 2 as 4 divided by 2. And I've got log base 5 of x is negative 3/2. All right, so now the output of a log function can be negative. I just can't have the input to a log function be negative or 0. So we've gone as far as we can here. So let's rewrite this equation that's in log form as exponential form. So the base is 5. The logarithm equals the exponent. So the exponent on this base is negative 3/2. And that's equal to our answer x. All right. Occasionally you'll see directions that say don't give your answers as negative exponents. So you might see it written like this. But then remember that 3/2 is actually a square root. So what this is saying is that you have 1 over the square root of 5 cubed. So then they're going to say, well, hey, you got to rationalize that, which you could have stopped right there for me. I don't care about that. But I just want to illustrate sometimes that you do see your same answer in different forms. When I multiply these guys, the radical goes away. So it's very likely if it was a standardized test that you would see a choice as the possible solutions to this equation. Let's get a decimal approximation to this. It may just be easier to key it in like this. Negative 3/2. Alright, so to 3 decimals, I'm getting 0.089. If I wanted to key it in like this, let's see, second square root of 5 raised to the 3rd power, that being divided by 5 raised to the 3rd power, and I got the same value. Okay, now let's if I were wanting to check that on the calculator, I would have to rewrite this as log of x over log of 5 by the change of base formula plus 2. And then the question is that equal to 1/2? So let's bring my calculator back up. Let's just use my approximation. The calculator does have the answer this answer stored in its memory to a lot more decimals. So we can just bring that answer back and then go divide it by log of 5. And we should definitely, if I add 2, we should definitely get 0.5 here. Let's hope that we do. There we go. We do. All right. If had we said log of 0.089 divided by the log of 5, it might have a slight round off error since this is an approximation, but I doubt it. Oh, it did. 0.497. Okay. So, but anyway, uh, here's our answer. We could have stopped here. I wanted to illustrate that answer could be rewritten as this guy. So either these say the same thing, and these are both exact values, and we use a scientific calculator to approximate that number to 3 decimals. And we plugged it in and checked, and we saw that our answer does check. So uh, I'm going to do the next one on this video too, rather than stopping. All right, so on the left-hand side, I see 2 terms. It's the first term that has my variable of interest. I'm going to subtract 10 from each side. I've got 4e to the is equal to -8. Well, right now I can stop and say, whoa, 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 whoa. Something is crazy is going on here. I've got +4 times, well, this e, we've said it many times that a negative number doesn't, negative exponent doesn't make your answer negative. The range of this is positive real numbers. On the left-hand side, I have a positive number times a positive number. No way can that equal negative, so this is a no solution. All right. Hope that helps, and I'll do the rest on another video. Talk to you later.